Hi everyone, welcome to all of you on my YouTube channel. I'm Ankit Misra. I'm teaching for Great Chemical Experience from last 4 to 5 years. So I'm requesting you all, those who have not subscribed my channel, please go and subscribe the channel and don't forget to press the bell icon so that whenever I'm putting any new video, you will get the notification. So here you can see that I have started the revision series of chemical engineering subjects. So here I am teaching right now chemical technology. So in the previous lecture I have already discussed about the H2SO for production industry. There I have discussed about the contact process, lead chamber process and DCDA process. So contact process was very important, and again DCDA process was extended version of the contact process where double contact and double absorption is happening. Due to this particular reason, yield of H2SO4 is being increased. So the catalyst that was used in contact process, earlier it was used as PT, but the quantity of PT required for per ton of production was very high that compared to the V2O5. So right now V2O5 as is used as a catalyst. So here you can see that in contact process this happens in 3 steps. That the first step, sulfur is getting oxidized to form SO2. This reaction is happening in exothermic condition, and again SO2 is getting converted into SO3 in presence of V2O5 catalyst. Again this reaction is exothermic. After that SO3 is getting absorbed in H2SO4 because SO3 is not getting absorbed in water. That's why H2SO4 is required, concentrated H2SO4, and it forms H2H2O7 oleum, and then it is being diluted with water, and then ultimately it will form the H2SO4 sulfuric acid, right? So here you can see that purity of H2SO4 that is being produced here is 98 to 99%. And here you can see the advantage of using V2O5 as a catalyst is this is immune to poison, requires less quantity, and that's why this reduces the cost of production, and it can be easily regenerated. So these are the equipments that is being used to produce the H2SO4, that is Bernal catalytic converter, oleum absorption tower, and concentrated, that is 98% H2SO4 absorption tower. So this process is happening in series. So if question is being asked from this particular topic, that arrange this in the series, series wise, so you can use this things right now. Again, lead chamber process catalyst being used here is NO or NO2. Here you can see, and the process is happening same as is getting reacted with SO2, and but here in presence of SO2 it is SO2 react with NO2 or water, and it is forming H2SO4, and again NO is getting regenerated in this process, right? But what is disadvantage of less lead process, that this purity of H2SO4 that you are getting here is only 62 to 68%, something like that. So purity is very less effective, and large space is required, right? Now coming to the DCDA process, here only I'll be talking about that it is able to produce 99.8% of H2SO4, and it involves two catalytic converter. Okay, so now I'll be moving towards the next topic, and that is the phthalic anhydride. So this one is the phthalic anhydride. So again I am telling you, so what kind of reactant is being used, what kind of catalyst is being used, and what is the product. That three things can be asked from here. So in case of phthalic anhydride, typically you can see that this is happening due to the catalytic oxidation of orthoxylene or naphthalene, right? And using vanadium pentoxide is a catalyst. So two most important reactant is there, orthoxylene and naphthalene, right? So let's say naphthalene will get oxidized in presence of vanadium pentoxide, and it will form phthalic anhydride, and again water will be formed. And again one more important chemicals that is there is your orthoxylene, plus it will form, sorry, here it will be 4.5 O2, and here it will be 3 O2. Reaction is not going to be asked, but again you have to understand that what kind of reactant and product is there. So phthalic anhydride plus water molecules will be there, so 3 water molecules will get liberated. So these two reactants are there, that is going to form the phthalic anhydride in presence of vanadium pentoxide, and so here also you can say that CO2 will get liberated. So now you can see the product that is being formed in the reaction, that is carbon dioxide and H2O is getting formed due to the naphthalene oxidation, and only 3 water molecule is coming due to the orthoxylene oxidation, right? This was all about the phthalic anhydride. Coming to the maleic anhydride, that is also very very important. Ma. So most of the people teachers hear about the reactant in maleic anhydride. So obviously one is your benzene. Benzene oxidation in presence of obviously vanadium pentoxide catalyst, it produces your maleic anhydride plus CO2 plus H2O. But again, some other, so most of the people knows about this benzene oxidation only for maleic anhydride production. But again, some other reactants are also there that can produce the maleic anhydride, and that can be asked in your examination. So sometimes your butane or butene also getting oxidized to form the maleic anhydride in presence of molybdenum based catalyst, right? So oxidation of butane is also there. Oxidation of butane or oxidation of butene. Is that clear? So when we talk about the oxidation of butane, so C4H10 will get oxidized in presence of obviously vanadium pentoxide. It will form C4H2O3 plus 4 water molecules. So butane's oxidation can also give the maleic anhydride, right? So this is our maleic anhydride. So you have to remember that butane and benzene will get oxidized in presence of vanadium pentoxide catalyst, and you will get the maleic anhydride, right? Now coming to the most important process, and this is very important for the GATE examination, that is oxo process. And sometimes this process is also called as hydroformylation process. So when we talk about oxo process, this is also known as hydroformylation. This is an industrial method for the production of aldehyde by reacting alkane with syn gas. So if I am talking about syn gas, so first you should know the formula of syn gas. Syn gas is CO plus H2. That is also called as sometimes synthesis gas. And the alkene react with syn gas in presence of metal catalyst. It will form aldehyde. So alkene is there. So you will be having alkene plus syn gas in presence of catalyst, that will be your metal catalyst. It will form aldehyde. Is that clear? So these things only you have to understand, that hydroformylation or oxo process is being used to produce aldehyde, and how aldehyde is getting formed while oxidation of when alkene reacts with carbon monoxide and hydrogen, that is syn gas, it will produce the aldehyde, right? Okay, next I'll be talking about the preparation of diammonium phosphate, right? DAP. If I am talking about the formula of diammonium phosphate, that will be equals to NH4 whole twice HPO4. NH4 whole twice HPO4. This is your diammonium phosphate. So diammonium phosphate is also commonly known as fertilizer, buffer, or source of nitrogen, phosphorus in various application. So here we'll see that how this thing is getting formed. So ammonia will react with H3PO4 phosphoric acid, and it is going to form the diammonium phosphate, right? So generally the reactant that is being used is ammonia plus H3PO4. So first it will form monoammonium phosphate and then diammonium phosphate. So directly I am writing NH4 diammonium and phosphate HPO4. So right, so the pH which is maintained here is 7.5 to 8.5. That is the neutral pH for this reaction condition. and water is also getting produced in this particular step, but due to evaporation excess water is getting removed, and the crystal of NH3 is getting formed. Is that clear? And this is being used to as a uh, what you can say, that as a fertilizer for your crop production. And the stoichiometric ratio of phosphoric acid to ammonia, here you can see that used to be equals to 1:2. So 2 moles of NH3 will be used and 1 moles of this thing. So the stoichiometric ratio of obviously ammonia is to S3PO4, you can see that is equals to 2:1. Okay. Okay, so that's all. I'll end the lecture here only. In the next lecture, I'll be talking about single superphosphate, triple superphosphate, and the petroleum refining. Okay, thank you. See you in the next lecture.